Hello, welcome to the Magoosh Plugging in Numbers workshop. Allow me to introduce myself, maybe. If I can get the slides to go, there we go. I am Brian, and you may remember me. If not, I live in New York. I have been tutoring with Magoosh for over around 4 years. A lot of GRE tutoring, a lot of creating math content, like the class we're gonna run through here today. And please say hello to Jen. She will be monitoring our chat for us today, and she will pass along all your pressing and burning questions. On the housekeeping side here, we will be sending the recording out afterwards. So if you have to leave early, if you got here late, if you weren't able to be here at all, and you are watching this recording, you did receive it already. We will have a Q&A throughout. We'll be picking off questions after the problems we work through. We'll have some larger breaks for generalized questions in the middle, at the end as well. Be prepared to participate. We'll talk about that in a second. This math class is going to be a little more active than some of the other math classes you may have been to. And lastly, in regard to the Q&A, if we don't get to your questions, or if you are watching this recording later today and you do have questions, feel free to reach out to us at help@magoosh.com. Okay, what are our goals for today? So we have 3 goals. We're going to learn how to use smart numbers effectively for plugging in numbers. We're going to solve without using real math, and I'm going to underline that here, and we're going to emphasize that. Yes, a lot of these questions, probably all of them, could be solved with algebra and real math. That is not the point of today's class, and we are not going to be doing that together. And I encourage you to not be doing that on the side as well as we're practicing these questions together. And lastly, we're also going to work through those spots where plugging in sort of breaks down and we feel like we run into a trap and we have to figure out like why these numbers didn't work, or do I need to test more numbers? It's usually a point of frustration with the strategy, so we'll try to work through some of those too. Okay, the last thing I will say here before we jump into these plugging in numbers basics, this is a really different format from the math classes we have been doing. So for our returning champions, your feedback is very much appreciated. Feedback will be appreciated from everyone at the end of this class. But if you have been to our other math classes, please let us know how you like this one compared to the others, because maybe we can use this format for other classes too. Okay, so what we're going to do now, we're going to go over the plugging in number basics just so we're all on the same page here about how to use this strategy. And then we're going to do some mixed practice together. Some of it will be a little guided by my hand, some of it will be a little on your own, and then we will reconvene and recap together. But for now, let's just review our plugging in basics here. So first, why plug in? So we want to plug in because this allows us to turn algebra into simple arithmetic. So going back to goal number 2, to avoid using real math, we want to avoid, sorry for hitting the microphone, we want to avoid doing complex algebra, complex calculations when we can turn things into simple arithmetic that we might be able to just punch on the calculator. Okay, big things we're going to be looking for here today. The Q, our Q for when to plug in, our primary Q is when we see variables in the answer choices. And so whenever we see that, it should always be the little light bulb in our head. Okay, I can probably plug in here. Again, there will be times when that breaks down, where that doesn't make sense. There will also be times when there are not variables in the answer choices, but we can still plug in. But again, our primary Q is if I see variables in the answer choices, I'm going to plug in. Constraints. So this is the next thing we need to consider. Once we recognize that we can plug in on a question, we need to figure out what types of numbers are we allowed to plug in. So if it tells us positive integers, we should know not to plug in something like a negative fraction or 0. So we always want to pay attention to what are the constraints of the question. What types of numbers or values am I allowed to plug in for my variable or variables here? Then smart numbers, we talked about this. This is another one of our goals here. So for plugging in, generally, you can use just about any number that matches the rule of the constraints, but there are numbers that are going to be smart numbers to use, easier numbers to use that make this testing work more efficiently. And so we want to think about how to leverage those smart numbers rather than just plugging in any old number there. And then the last thing that we will work on here today, again, is watching for traps. So there are going to be times, again, where we plug in numbers and multiple answers seem to be true. Or we plug in values and we're just running into trouble, like making them work easily or to test the question easily. And so we want to make sure that we're always looking out for those types of traps that are meant to catch plugging in number strategists. Okay, before we jump into practice questions on the plugging in strategy, I will speak for myself. I will not mull people for questions now. I cannot speak for this guy here, but we will take him at his word. Any lingering questions out there, Jen?
No questions just yet. I know a couple of you out there are having some sound problems. I'm looking at it on our side, but I can hear stuff and a lot of other students can. So if you're having sound problems, maybe check on your end or drop me a message in the chat. Brian, a quick question. What does multiple correct answer questions mean? What does that look like on the test?
Sure, so that is a great question, and that language maybe is not super clear on my part. So what I'm talking about here is on a single answer multiple choice, when we're plugging in numbers, certain numbers may show that answer choice A could be correct or answer choice B could be correct. But it's a single answer multiple choice, which means really only one of those answers is the truly correct answer. So sometimes when we plug in numbers, it may show a false positive, so to speak. And in that case, we'll need to pivot and adjust the numbers that we're plugging in to reveal which is the correct answer. But we'll get to work on that a little later here today. Before we do that, I am going to turn my camera off now. Maybe that will help a little with some of the audio too if some of the streaming data coming through is reduced. But the real purpose of this is just so my slides fit better on the screen for all of you so that we can jump into this practice now. So like I said at the start, this is going to look a little different than the math classes that we are used to. But we will all get through this together. Hopefully you will laugh, I may cry, but let's see how this goes. So first up here, our first practice question. So take 30 seconds to read this question. Do not solve this question yet. We're gonna work on this poll first. So just review this question and think about what is our primary cue that we should be plugging in here. Okay, I'm gonna go ahead and launch this poll now. Again, what is our primary cue for plugging in on this question? Great, lots of answers coming in. I'll leave this up for about 10 more seconds. All right, great. We're gonna close this out and we could take a look at some results here together. So pretty reasonable split here. The majority of people obviously on variables in the answer choices. That is going to be the best answer here. But we could talk about the other answer choices here quickly too. Question format. So I don't think question format here necessarily lends itself to plugging in on its own. This is just a standard multiple choice question format. Yes, we have the multiple choice. Yes, there are the variables in the answer choices, but it's the variables in the answer choices that really tell us we should plug in here and not necessarily the format. Because if we had a regular multiple choice question, but there were not variables in the answer choices, the format of the question is still the same, but we wouldn't be able to use the strategy. I like the topic answer here better, even though that was the least responded one. Percentages usually, or percent type questions would usually lend themselves to this strategy. So maybe when we see that topic, we want to be leaning toward, oh, I might be able to plug in here, but our primary cue again should always be we see those variables in the answer choices. Let's come back over here. We have another poll to look at. So we know we're going to plug in here now. What types of numbers are we allowed to plug in? So just glance over this again for 10 seconds. Think about what are the numbers that are allowed, what are our constraints. I'm going to launch a poll here. It will be a select all that apply poll. So any types of numbers we are allowed to plug in, go ahead and select those, and I will go ahead and launch this now. And we'll take about 10, 15 more seconds to get some answers in. All right, looking good. Let's close this out and take a look at some shared results here. Majorities of people on the whole numbers, on positive numbers, those look very good. Lots of people on fraction 2, nearly half fractions are acceptable here. I would say maybe not the smartest number to use, but definitely allowed within our constraints here. We have a number of people on the negative numbers and 0, and we should just talk about that here quickly. So we're dealing with prices here, and it probably doesn't make sense to use negative numbers or 0. It's possible we can find a way to make that work here, but generally we should be thinking about real world scenarios. And the wholesale price of something is not going to be a negative number. It's not going to be 0. If we were to plug in 0 here, it's going to break the question. Everything will work because if we increase something that was 0 or we decrease something that was 0, it's going to stay 0. So when we see a real world sort of price-based question like this, we should just be thinking positive whole numbers are our easiest smart numbers, but fractions may be allowed as well. Okay, so let's finally go ahead now and figure out what types of numbers we should use. So what I want everyone to do now is to submit some smart numbers that we might use to test this question here, and then we're going to do that together. So you could just drop those numbers in the chat for me, and one lucky winner will have their number selected. So go ahead and take a moment to do that. Awesome, lots of numbers coming in. See, very, very similar numbers, which is very, very good. The common number I see lots and lots of people dropping in here is 100. And that is the number we are going to start with here. And that should be our smart percentage number. So we'll just put that up here. Smart, and bear with my, smart, bear with my handwriting here. Smart percentage number should be 100. And we're going to say here in our case then that P equals 100 as well. And what we're going to do now is we're just going to walk through this scenario, the story in this question, and rather than using this P number, I'll make my pen a little darker here. Rather than using P in this sentence, we're just going to plug in 100 wherever we see P. So let's just read this together. The wholesale price of a new laptop is $100. The laptop is sold at a retail price 60% greater than the wholesale price. Well, if our original wholesale price was 100, then for a 60% increase, all we need to do is add 60. And that is the magic of using this number 100 to start. When we have percent changes and our original starting point is 100, we can just add or subtract that percent change. So in this case, if we want to increase this by 60%, we're just going to add 100 plus 60. And that gives us our retail price of 160. That's great. What happens next? During the sale, the price of the laptop is reduced by 25%. Okay, so we know we have this retail price of 160, and we need to reduce this now by 25%. There's two ways to think about this. We could think about this with our multiplier as 1 minus 0.25, and we would do 160 times 1 minus 0.25. Or we could skip this step here, and we can also think about this as 160 times 0.75. And this is going to be the faster way to do this on your calculator. If we're taking 25% away, it means 75% remains. And so we should just be looking to figure out what is 75% of 160. Now again, I can do this with mental math. Many of us maybe can do this with mental math as well. But as Maury Povich has recently told me, I am not Mike McGarry, and so I am allowed to use the calculator, and you should too. And so we're going to do that right here really quickly. And if we punch in 160 times 0.75, we're going to figure out that this would equal 120. And so our final retail price, or final sale price here is 120. What do we do now? So we're close, but we have to find an answer. And our final step here is we're going to come back to this number, P equals 100, and we're going to plug that in to each of our answer choices here to figure out which one is going to equal this 120 number that we found if our original p-value was 100. So if we do that here quickly, we have 1.1 times 100, and that's going to equal 110. And again, if you have trouble with this, you could go to the calculator. We're going to do here 1.2 times 100, and that's going to equal 120. And we may star this because that probably looks pretty good to us here. But we should always be testing all of these answer choices. Going back to that earlier question about what is a trap answer choice or a false answer choice, it's possible another one of these answer choices would equal 120 when we plug this in. So we'll quickly check here, 1.35 times 100 equals 135. And we could see the pattern here. We're just shifting this decimal over. So answer choice D would be 145. Answer choice E would be 185. And we'll see here only answer choice B matches this price we found when we use P equals 100. Now, before we go on, I know this probably looks like magic that we use this number 100. Oh, it works very easy. It's a percent-based question. But what if I didn't use this number? What if I had used a different number? So what I will invite everyone to do now in the chat, is to drop in a number that maybe is a little unwieldy to use. And we can just run through this quickly to see that no matter what number we used, that this will work. So someone give me a real nice challenging number to try to test this out here. And I'm gonna go ahead and clear this screen so we can test this out. Okay, see some numbers coming in. And lots of very ugly numbers. I appreciate this very much. Okay, I see, we'll take 87 here. So we would do the same thing here. We would say that P equals 87. And we're just gonna walk through this same scenario here again. So the original wholesale price is $87, and we're gonna increase it by 60%. So this time we can't just add 60 because our starting price is not 100. So we're just gonna have to do like this, 87% times 1.6, our multiplier, and that is going to absolutely be done on the calculator. And we would just do 87 times 1.6, and that's going to give us our new increased price, 139.2. We're going to take that number, 139.2, and we would multiply it by, that's 75%. We talked about why we can multiply it by 75% here. And so if we do that very quickly, multiply this, and we get this final price. What was that number? 104.4. Okay, and again, we would just go back in now and we're gonna plug P equals 87 to each of these answer choices. You can do that on your own here to see that only one will work. I will quickly test answer choice B, the correct one for us. And if we do that, we will see 87 times 1.2 equals 104.4. That was the number we were looking for here. And so no matter what, as long as we pick some positive value here, whether it is a whole number, whether it is a fraction, this system will work. So don't worry overly about picking the perfect smart number. You don't want to spend too much time thinking, is this the right number? Is that the right number? Pick a number and go. But we should recognize when it's percentage questions, we're going to use that number 100. Okay, let's go on to another example here. We're going to start with our Q again. So quickly take a look at this question, and then I'm going to launch this poll. What is our primary Q here again? We are going to hammer this part home today. Okay, take about 5 seconds, and here is the poll coming now. What is our primary Q? All right, take about 5 more seconds here. All right, let's close this out and share some results. Awesome. So more people on variables in the answer choices this time. That is good. And maybe we'll start to recognize the pattern here. Less people on format and some people on topic. And I agree with this breakdown here. There's maybe a little indication in the topic we're dealing with integer properties, and those tend to be good questions to plug in again. But our number one cue here is we see those variables in the answer choices. And we will also come back here now. Oops. And we have one more poll. What type of numbers, what are constraints, what type of numbers are allowed to be plugged in this time? So take a minute to rescan the question. And here comes our poll. What types of numbers can we plug in this time? All right, lots of answers coming in. Take about 10 more seconds. All right, let's go ahead and take a look at some results here. Huge spread here. That's good. Let's talk about everything. So, good answers here. Positive numbers look good. Negative numbers look good. Odd numbers look good. We run into a little trouble with fractions and even numbers here. So remember right here, it tells us from the start, m is an odd integer. So this is where we need to pay very close attention to the language in the question. If m is an odd integer, then we should not be plugging in fractions or even numbers. Okay. One other thing here, oops, to talk about before, or let's actually then, based on our little survey there, and knowing now that we want an odd integer to plug in here, I'd like to take some smart number submissions in the chat again. So what might be a really smart number we could use to test this one out? Good, wonderful. Everyone is very fast and you all are pretty close in thought here. I see some good combinations of numbers, but the most common one popping up here is 1, and I like that one a lot. So we could say that m equals 1. Before we go on here, I do want to highlight this part because this is going to inform our strategy. Must be an even, and we should be reading that is always in every single instance which answer choice is even. And that's going to be useful for us strategically, and here's why. We'll never be able to test answer choice A here and show by that single test that answer choice A is the correct answer. But what we can show through testing is that an answer choice is not the correct answer. If we can show any single instance where answer choice A does not turn out to be an even integer, then we know we can eliminate answer choice A. And through this process of elimination, by disproving 4 answer choices, we will know that the remaining answer choice is in fact the correct answer. So what I want everyone to do now is, using this m equals 1 number, go ahead and test the answer choices. And in about a minute, I'll launch a poll to collect some answers here. So go ahead, I encourage you to use the number that we're using as a group here. If you want to go rogue and experiment with a different number, I can't stop you, but we will be modeling this using the number 1 together. So take a minute to do this now. Okay, I'm gonna launch the poll now. The question is in the poll, so you won't lose it. All right, take about 10, 15 more seconds to submit some answers. All right, looking good. Let's go ahead, close this out, and we can share some results here. That works really, really well. Very good, everyone. Answer choice E is in fact the correct answer. I'll do a very quick modeling of the answers here for everyone, but it seems like we're on the same page with this test here, which is great. So let's go ahead and just see what your testing should have looked like. So if we did test answer choice A, and we were using this m equals 1 value, then we would have just plugged in 1 squared minus 6 equals -5. And we would know we can eliminate this one. We can eliminate this because that is a negative integer, or the negative doesn't matter. We are looking for an even integer, and this is an odd integer. We do answer choice B, we end up with 5 times 1 plus 10. That equals 15. Again, that is odd and that is out. We would do C is 10 times 1 plus 1 equals 11. That is odd and that is out. We can do D is, we maybe recognize this as a really ugly one right off the bat. 30 over 7 is 30 over 7. That is a fraction. That is wrong for a lot of reasons. That is out. And we should know really without even testing that answer choice E does have to be the right answer. But if we're unsure of that, we can just test it quickly. Get 4 times 1 over 2 does in fact equal 2, and this is our even integer. Again, using this number 1 was really smart here. We could have used another number. I see some funny numbers out there in the chat, like 29. 29 is going to work for this too, but using 1 makes all this testing super, super, super simple. We probably don't even need the calculator, but if we did, it's quick, easy arithmetic to punch in. Take a pause here for questions on this problem, and I realized I forgot to answer any questions from the previous question. So do we have questions on either of the first practice examples we've looked at here today?
We have a few questions from the first problem. So we had a couple of people asking, why couldn't we have multiplied 25% of 160 and solve?
That is a great question. So we can do that part of it, but remember here it's telling us that the price is reduced by 25%. So if we find the 25% of 160, that would be 40. We would still need to subtract that number from 160. So we're doing an extra step there. What we're doing there is saying, let me write down here in a different color, just so we can see that it's different. So we would have 160 times 0.25, which equals 40. This is not the final price. This is the discount. And so we would need to take this 40 and subtract it from this 160. And that gets us to this 120 number here. But if we do not do that, If we just have 40, first we'll see nothing in the answer choices would have given us 40. But again, this 25 is what was taken off. It is not the final price. Other questions from here?
How about one more question from here? How did we get the 1.6? Can you walk us through that?
Sure, that is a great question, and I did probably rush through that here. So this is our multiplier here. We are increasing by 60%. So the way we form a multiplier for a percentage increase is 1 plus that percentage as a decimal, right? So 60%, oops, 60% is the same as 0.6 as a decimal. So when we are forming this multiplier, what we're saying is 1 plus 0.6 gives us this 60% increase. Cool. Other questions here?
How about one more kind of general question, and we may get into this more as we move forward, but someone's asking, can't taking a simpler number give us an answer for multiple choices that might be wrong? Or is there sometimes where a simple number can throw us off track?
Absolutely, 100% that is a true statement, and I will never try to claim otherwise. We will actually see that a little later today, and we'll talk about how we can pivot when that happens and what we can do to work through that. That is a great question, and that is a fair concern here, but we will work through that as well. How about from this other question, from the M question? Were there any lingering questions there?
No lingering questions from there, but everyone just keep questions coming throughout the chat. I'll add them to throughout the class, not the chat. I'll add them to the list and we'll take them at breaks.
Yep, and we're going to do one more practice question, and then we'll take a little break for just generalized questions as well, so you can feel free to drop those in anticipation of that. But let's go ahead and take a look at another question here. So take about 10-15 seconds to look at this, and then we're going to do this Q poll again, and I think you all know the answer coming. All right, here's our poll. What is our primary Q to plug in this time? All right, about 10 more seconds. All right, awesome. So we'll close this out. We'll share this again. Looking pretty good, and I'm okay with these results. Again, still variables in the answer choices as our #1 primary, but format, especially based on what we just saw in the last question. Format's probably a fair answer here, right? When we see this must be the greatest language, we probably should recognize like, oh, this might be a good chance to test because I can eliminate the ones that are not always the greatest. So I'm okay with that format answer here as well. And we should know what Q is coming or what poll is coming now because we are going to talk about what types of numbers we are allowed to plug in for this one. So again, think about our constraints, what is allowed, what is not allowed. And let's go ahead and look at this poll. All right, take about 10 more seconds again. All right, let's go ahead and close this one out. We could share some results. Okay, so there are lots of types of numbers that are allowed here. Whole numbers are good. Fractions this time will be okay. Negative numbers look good. Let's talk about 0 and positive numbers here. So remember our rules of the question comes from right here. This is where we're going to get our constraints. That 5r is less than 2t, which is less than 0. So if we think about this now, what this is telling us is 5r and 2t are both less than 0. And in order for that to be true then, right, we need a positive 5 times a negative r to get a negative value. If 2 is positive, we need t to be a negative value. And so what needs to happen here then is that we cannot use positive numbers because that will not allow our rule, this inequality, to be true. So we do need negative values for r and t. Same issue with 0, right? If we plug in 0, then 5 times 0 is 0, 2 times 0 is 0, and this inequality is not true. But fractions will work, whole numbers will work, negative numbers will work. Go ahead to the chat and give me some numbers for R and T. Try to put them both in one thing so I can pick someone's pair of numbers. But drop those in the chat and then we can do some testing. Good, good, good. Lots of numbers coming in here. I like what's going on here. I see some very clever people here. So I think that this is what's going on in the chat that I can see. So the majority of people are giving me something like this, where r equals -2 and t equals, that's not a good pen color. Let's try that again. Where r equals -1 and t equals -2. And that is great. And I think that's probably where most people default here. Or maybe they have them the other way. It doesn't matter. I see some really smart number pickers there, though, who are doing this instead. They're saying r equals t, which equals -1. And this is very smart, and it's also very important to recognize here. So just because we have two different variables does not mean that they have to be different values. The only thing that needs to be true when we choose our numbers is that the rule of the question, the constraints, must be true. We must observe that. If we were to plug in -1 for r and t here, we would observe that. If we plug in -1 for r, we get -5. If we plug in -1 for t, we get -2. And if we complete our inequality here, -5 is less than -2, which is less than 0. And so this is the easiest number that we can test here. It does not mean that these numbers, -1 and -2, are wrong in any way. And I assure you, the majority of people drop those two numbers in the chat. But the smartest numbers, and we really want to get good at thinking like, what is the absolute smartest thing I could do here when I'm testing, would be to make both of these equal to -1. So let's go ahead now, and I want to walk through this test together because it's a little other tricky thing we can do with our answer choices here. So we're going to say that r equals t equals -1, and let's go ahead and test answer choice A now. So if we do that, we get 2 times -1 minus 5 times -1, and that's a whole big messy thing, but it ends up just being -2 plus or minus, where's my eraser? To being -2 minus -5, which is really the same as -2 plus 5, which equals 3. Now, before we test anything, I'm going to launch another poll. We've shown right now, remember we have another one of these must be the greatest. So any case where an answer choice is not the greatest, we can eliminate it. So based on our test of answer choice A, what answer choices can we eliminate right now? Okay, see a lot of answers coming in all over the place. We are not answering this question. We are figuring out what we can eliminate just based on our first test here. So take about 5 more seconds and I'll close this one out. Okay, let's go ahead and share results here. So a lot of answer spread here we could see, but a super large amount of people on answer choice E, and that is the one that we should be focused on right now. So let's go ahead and jump back here and take a look as to why that is. So what we showed when we tested here was that answer choice A could equal 3. We don't really know what B, C, or D could equal yet based on the numbers we plugged in, but we do know 100% that 0 is less than 3. And so when we think about this must be the greatest, we know we can eliminate answer choice E. We've shown a case where answer choice A could be greater. So let's come back and let's keep testing then. So let's look at answer choice B now. So we have 5 times -1 minus 2 times -1, which is the same as -5, minus -2, which is the same as -5, plus 2, which equals -3. And we're going to have the same poll coming again. This time, which answer choices have we now eliminated? Okay, looking good here. I'm going to close this one out and share results. So very good this time. I see answer choice E, the number went down because we've already eliminated it. I assume we still eliminated is fine. But the big one that we've eliminated now is answer choice B. 100% we can get rid of that. So coming back here again, we've now shown that answer choice B equals -3. If we know answer choice A could equal +3, we know answer choice B is out. Now we're going to test answer choice C, but we're going to test answer choice C really smartly and really strategically. So if we notice here, we look at answer choice B and answer choice C, we should notice inside this parentheses is the same thing as what we just found for answer choice B. So if we substitute that in, we really just have a -3, which is the same as +3. Answer choice C is just the negative, the inverse, the reverse of answer choice B. Now is the last final tricky elimination poll. So if answer choice C could also equal 3, what can we eliminate now? All right, looking good. Take about 10 more seconds for this one. All right, let's close this out and look at results. And this looks pretty good here, everyone. Majority of us have eliminated all the right answers, it looks like. And the one that is only at 9% answer choice D should still be in the game. So that looks very good. Let's go ahead and quickly see what is going on with our answer choices here and why we should know D is the answer. So we've shown answer choice C is also equal to 3. And again, I know I keep harping on this, but must be the greatest means always exclusively the single greatest answer. And so if A and C both equal 3, neither is exclusively the greatest. And so we should be able to eliminate A and C, and even without testing it, we should know that answer choice D is in fact the correct answer here. Okay, so I have the question break. We're a little pressed on time. I want to get to these practice questions where we could see what happens when plugging in breaks down. So I'm gonna hold on the questions and hopefully we can get to them a little later. We're gonna skip the Q stuff for now. We're gonna shift as we do our practice. I want you to be doing more of it. So when we look at this question on the screen, you should recognize already what are the Qs. You should be able to figure out what are the constraints here. And so I want to go straight to what are our smart numbers here? What might be smart numbers we could use for T and G? Great, I see lots of things coming in. That is good. And I see one set of numbers here that a couple people have submitted, and we're going to use that set here. So thank you to those of you who have submitted 100 for T and 50 for G. So we'll put that down here. We're going to say T equals 100. We're going to say that G equals 50. And we're going to go ahead and we're going to work through this problem here. Okay, so I'll put those up on the top of the screen here for us too. T equals 100 and G equals 50. Okay, so what does this story tell us then? So it's telling us that Paula has 100 tokens. If 50 tokens are green, what percent of Paula's marbles are not green? So using these smart numbers, that should be really easy for us. If 50% are green, then we should know 50% not green. And so all that means to us then is we're going to test our answer choices and we're going to try to figure out which one of these equals 50. We are looking for the answer that gives us 50%. And so let's go ahead and test these quickly. And if we test answer choice A, right, we get 100 times 100 over 100 minus 50. We probably don't need to continue at this point. We should recognize that this 10,000 in the numerator divided by 50 is not going to be anywhere close to 50. We don't have to be good at math. We don't need to be able to solve this. We should be able to look and say, this is going to be a number that is much too large. And so we should be able to eliminate it. If we aren't able to do that though, remember you always have your trusty little calculator here, so you can just do your calculation there as well. Okay, let's test answer choice B now. So if we do that, we have 100 times 50 over 100. Now this one looks a little more interesting because we can slash these hundreds here, and that leaves us with 50. And so answer choice B works. And so my question now for the class is, should we continue to test at this point? So we've shown answer choice B works. Should we continue to test? All right, take about 10 more seconds here. All right, let's close this out and share some results. So pretty split, but the majority does have it here. The answer is yes. I will give a little credence to the only if we have time answer there. If you're super pressed for time, where you probably only have about 30 seconds left per question, you maybe have to just trust that this is the right answer. But under ordinary circumstances, yes, we should be continuing to test. And so what I want everyone to do right now is to continue testing on your own. So take about 90 seconds to finish doing the testing here on your own, and then we can do it together quickly. Okay, so let's do a little testing together. Hopefully we got through some of that. So if we pick back up here with answer choice C, right, we would have had 100 minus 50 over 100 times 100. And again, this is one we probably look at and say, oh, that numerator is going to be way too small. This number is way too small. And so we should be able to eliminate C. We test answer choice D here. We're going to have something similar. We're going to get 100 over 100 times 100 minus 50. And again, we should probably recognize, oh, that numerator is going to be much too small compared to the denominator. So we could eliminate D. And then E here is our special case that maybe gave us a little trouble here. So we had 100 times 100 minus 50 over 100. And what happened this time? Well, these hundreds canceled out. We were left with 100 minus 50. And so E also equals 50. And this then presents a problem for us because answer choice B looks good, answer choice E looks good. And I think this is the case that we have been sort of hovering around and wondering what do we do throughout this class. So here's the really, really, really easy thing you're going to do. All you need to do is adjust one number here. That's it. And what I will do is I will suggest a way we could do that, but you're open to try adjusting on your own too. But what I would suggest here is we can just change this G equals 50 to G equals 40. And now all we need to do, we've eliminated A, C, and D. We do not need to test those again. So what I want you to do now is just take 30 seconds using our new numbers, T equals 100 and G equals 40, and retest answer choices B and E. And then we're going to launch a poll to collect our correct answer here. All right, so here's our final poll between B and E. Which do we think is the correct answer? Very good. Take about 10 more seconds here. All right, let's go ahead and close this out and look at some results. Looking pretty good. 4-to-1 split here, and the answer choice E, that 100 times T minus G over T, is the correct answer. The majority has the correct answer here. So how does this work? How does this work so simply? So by changing G equals 40, that means here it's not 50 that are not green anymore, but it is in fact 60% that is now not green. And when we come back to test answer choice B, let's see if we have another slide we could do that on. So we could do that here. So we have T equals 100, G equals 40, which means the not green is now 60% not green. And so what that means when we test answer choice B, we get 100 times 40 over 100. And when we eliminate now, this only equals 40, but we needed it to equal 60. And we should know at this point automatically E is the right answer. We shouldn't even need to do that test. If we were really unsure, we could test it. We're not going to do it now. You can do it on your own. It will work. But when that plugging numbers breaks down, when we do show multiple answers could be true, don't panic. You just need to make a slight tweak to one of your numbers, and you only need to retest the remaining answer choices. You don't need to do all the legwork again. So you're at a 50-50 point already. Going back to that earlier question about should I keep testing if I'm out of time or if I'm pressed for time, I only have time. If you're in that 50-50 spot and you don't have time to test again, at least you still have a 50-50 guess. But ideally, you just need to make one small tweak and we will be able to answer this. Okay, one final challenge question that I want you to do most of the heavy lifting on your own here. I do want to just call for smart number submissions in the chat so I can put those up there and that you can all test this using the same smart numbers. So what are some smart numbers we can use for X and Y here? Yep, and I see everyone hammering this very quick. -1 for X, +1 for Y. That's going to look pretty good here. So why don't you all, let me change my ink here. But what I want everyone to do now is take 90 seconds and use these numbers, X equals -1 and Y equals +1 to test our two quantities here. So go ahead and do that now. Okay, so after having done this first test, what have we shown as an answer choice using these smart numbers? And if you didn't use these smart numbers, please don't submit to this poll because your answer is possibly different. Awesome, lots of answers coming in. Just take about 5 more seconds here. Great, let's take a look at our results. The majority of people on answer choice C, and that is the correct thing we should have shown if we tested with these numbers. We wouldn't have been able to show answer choice D yet. We can never show answer choice D after a single test, but answer choice C looks good. So what that means then is if we've shown answer choice C, we should know automatically answer choices A and B must be out, because if there is an instance where the two quantities could be equal, then it is not the case that A is always greater or B is always greater. The question now, what do we do at this point? Should we continue testing? So let's get some poll information for that now. Awesome, take about 5 more seconds here. Cool, let's share these results. Yep, right, we're mostly on this. Again, a little credence to the only if we have time. To the no people, we really do need to be testing here again to make sure that we expose any sort of discrepancies with our test. So I want everyone to go ahead then and, or yeah, I will go ahead and give us some new numbers from the chat because we're a little pressed for time here. So a lot of us have submitted -1 and 1 the first time around. Let's just make a simple change here. And instead of using y equals 1, let's go ahead this time and use y equals 2. And I want you to take about 30 seconds to retest again, and then we'll launch a poll to collect the answers. Okay, and if we use these numbers, x equals -1 and y equals 2, what did we show this time with our test? Which answer choice did we show this time? Awesome. All right, 5 more seconds. All right, let's look at results here. So I'll take B and D as both correct answers here. Really, the correct answer for this is B. On this specific test, we should have shown the answer choice B is correct. But those of us who are maybe getting a little ahead recognize if we've shown a different answer this time, then D should be the correct answer. Which does lead us to our final poll. We'll let everyone pick up a free, easy right answer to end the day here. What is the final answer to this question based on our two tests? And we'll take about 5 more seconds here. Cool. And most of us got there. Maybe some of us were still answering the second number test there. But awesome, yes, as soon as we have shown two different things can be true, answer choice D automatically is our correct answer, and we should be clicking that and moving on. So D is a correct answer here. To that larger point again about when should we be testing multiple sets of numbers. So the two cases are in a regular multiple choice question where the answers break down and we've shown multiple things could be correct. We'll need to tweak our numbers to show which one we can eliminate. Quantitative comparison is set up like this, super common to need to test multiple sets of numbers. And you should always be testing with that mindset of how do I prove or disprove answer choice D. End of presentation questions. I know we're right at time here. Jen, are there any like super common questions that we can knock out really quickly, one or two?
So I think one big one, and that relates to the last question, is with QC questions, because we often have to use multiple numbers, we have to test multiple numbers, that can be really time consuming. How would you suggest we strategize those types of questions?
Yep, so I think that is a great question and a fair point. So I think there's two ways to think about it. One, if you know those kind of questions generally slow you down as part of your pacing strategy, that should probably be like an auto flag and skip when you see a question that's set up like the one we just looked at. And again, it may be the case when you come back to you're like, oh, this one was a really easy one to test, and that's great. But if you know you're just a little slow there, just flag skip, get to something easier to start. In terms of doing the testing, this is where those smart numbers come in really, really handy. So if we think about that one we just did, by starting and testing -1 and +1, those tests are really quick and really easy. And automatically we were down to a 50-50. It was either going to be C or it was going to be D. We had eliminated A and B very quickly. What I usually say at this point is this: you're testing to prove D. You should never test more than 3 times. So if we happen to just change the numbers in that previous example and we kept showing C, we just have to trust that C is the right answer. It may be that we're not testing properly, and that's unfortunate, but you don't want to endlessly test numbers. Ideally, you're going to do 2 sets of tests, and you're going to expose answer choice D, and as soon as you've done that, that's the end of the question. But by the 3rd test, if you've shown the same thing, you have to just accept that's the answer and jump ship. It's unfortunate. That is one of sort of the catches with this strategy, is we can never be 100% certain on some of those QC questions, but your general mindset is 2 tests, I'm going to show D, or I'm going to just trust that answer. Any other little quick things I can address for anyone?
Just I think the final question, and I know we haven't gotten to everyone, but email us at help@magoosh.com, and I promise we will get to you. If you can just say a little bit more, Brian, about avoiding the trap of kind of picking a number that seems really convenient, but might pose some problems as we test other values.
Yep. So what I would say is I still encourage you to use that one that is very convenient. It won't always be the case that there's going to be a trap, and I think generally that's going to happen more on like the harder second section and just on more challenging questions overall. But like we saw on that question where we did use the easy numbers, 150, it did lead us into a slight trap, but it still got us down to a 50-50 point. And at that point, we just had to make a slight pivot and test the 2 remaining answer choices. And the reason that's good is because had we started with more challenging numbers, testing all 5 answer choices is more challenging. The more challenging the numbers you use are, the more challenging it is to plug in and test everything. So by using those convenient numbers first and eliminating the obviously wrong answers, then when you go back and you use slightly more challenging numbers, you don't have to test as many answer choices. And so even though the numbers you're using are harder, the overall process isn't. So I would still encourage you to use those convenient numbers, but just have that game plan for, if it fails, I need to make this slight pivot. As Jen said, I know there are loads of questions in the chat here today. Thank you for being a super active class. I know we ran a couple minutes over, and I will tighten that up for next time. Thank you all for coming. I hope you found this super helpful. And if you do have those lingering questions that we did not get to, just shoot them over to help@magoosh.com. But thank you all for coming, and enjoy the rest of your day wherever you are. Bye. Oops.